Hello everyone, this is Mustaqim. I am from Interactive Software Engineering and Analytics Lab from Department of Computer Science from University of Saskatchewan, Canada, and today I am going to present my paper titled Do Automatic Comment Generation Techniques Fall Short? Exploring the influence of method dependencies on code understanding. This paper has been published on the prestigious conference is 2025. So, what is automatic code comment generation? Given a source method, the task is to generate a natural language description so that you can understand what the code is doing. It is very helpful for beginners who are new to projects. So, in the slide, you can see there is a given source method calculate end top bound. So, and if you want to generate comment for that, or what automatic comment generation tool does, it generates a kind of summary like this, which tells you in simple language what the method is doing without specifying the technical jargon so much. So why this field is necessary? Because program for comprehension consumes up to 58% of developers time. That's a lot. And a developer's reading to writing code ratio is 10:1. So that's why code comments significantly improve understandability of the project, and which enables beginners for easier program comprehension and software maintenance. So we identified some research gap in the literature, like research has been progressed from information retrieval techniques to deep learning to pre-trained model to LLMs for comment generation techniques. Still there are some limitations, like for pre-trained models, when you fine tune with code and comment pairs, it ignores contextual dependencies. I mean, like when you give train a model with some code and comment, it cannot see what's inside the code. So it's just training with the code and comment example, but the method itself has a lot of method calls inside and another dependencies which we do not train with. And another thing is for LLMs, when we generate summaries by prompting LLM and giving some code comment pairs, uh, these examples do not feel like real ones, because for a particular code, the comment should see the comment have to be particularly for that code, not like the example ones. So we identified these two limitations. And suppose look in this function, there is a void close function, and it calls another function await close, and it's in a try catch block, and it does something. So what the current tools generate the summary, let's see. Suppose tool code, but it says closes the connection, okay, single, simple. And another method based on LLM, it says closes the bulk processor. Let's see how the original developer wrote the summary. The developer wrote, this method flushes any requests, prevents any future retries, closing the processor, and returns once any pending requests complete. So you can see original developer write lot of meaningful things in the summary of this method, whereas the automated tools couldn't do. The automated tools mainly aligning with the name of the function, not it's unable to explain what's inside this await close method. And the original developer knows what's inside the await close method. That's why he was able to write something extra, like the yellow marked line here, like prevents any future retries. By seeing only this piece of code, nobody can say what's inside await close. That's why we feel like this is a research gap, and fine-tuning pre-trained models and relying on LLMs by giving example, it's not the best technique. To figure out these things and to build up on the research gap, we have defined some uh, definitions, and we are proposing a solution. For example, see, here is a function like method, like add method. It takes two integer and it returns the summation of it. This kind of function which doesn't depend on any other function, we call these functions as independent method. And there are another kind of methods like the previous one, this close method. It calls another function await close, so it depends on await close. So this kind of await close functions which helps the close method, we define them as helper method. And the close method which depends on the helper method, we call this close method as dependent method. So we define two types of methods in practice: independent method and dependent method. So going inside the function to understand the logic is common human nature. Human obviously try to figure out what inside await close, then goes click on it and goes into it and see that, and then we understand what the close function does. Okay, that's basic human nature. So, and current approaches do not consider this scenario. They just take the code snippet and give it to their method, and and it generates summary. They do not care what's inside it, like what's the behavior of await close method here. So based on this assumption, we propose help.com that utilizes helper methods. These are the methods to generate meaningful code comments. We hypothesize that utilizing the helper method will generate better summaries and that will align with humans. Okay, so based on this, we have proposed three research questions. First of one is, to what extent does the evolution of dependent and independent methods vary in open source projects? By these statistics, we will be able to see in real world how many methods, what percentage of methods are dependent ones and what percentage of methods are independent ones. If the ratio of dependent methods are high in practice, then research focus should be given to this kind of methods while generating summary. And for research question 2, we explored how the existing approaches perform in generating comments for dependent methods compared to independent methods. We will see if we divide the methods in the dependent and independent ones, how the current approaches perform. Do they perform similarly or they perform different? And finally, based on the findings of RQ2, we will see to what extent does leveraging helper methods lead to the generation of higher quality comments for dependent methods. Okay, yeah. And this is the methodology overview for our study. First, we have mined 10 GitHub Java projects and based on popularity, and then we have extracted all the methods from the projects by using a parser called treesitter. And after that, we also extracted the dependent methods and independent methods, and for dependent methods we also tagged the helper methods by running scripts, and then finally we saved them in a database. We used MongoDB for our experiment, and for each method we then fetched method history to see how many commit changes or author attribution changes happen between independent and dependent methods to get the results of RQ1. Then from the saved methods, what we did, we suppose take a dependent method like this one, insert, and it depends on shift up. You can see shift up, and there is another method grow. So for this dependent method, we also extract the helper methods. It depends on the shift up and grow. And after extracting those, we designed a prompt, like we tell them to generate the java comment that can be written by a developer, and then in the prompt we give the original method body, and after that, to give more context, we give the helper method bodies. The helper methods are shift up and grow, and you can see we designed the prompt like that. And you can also see there are levels, like level 1 helper methods to level and helper methods. So by level we mean is that like immediate, like for insert functions, grow and shift ups are level 1 helpers because it's inserts immediate helpers. And what will be the helper 2 method? Suppose in shift up functions the shift up calls another method, so that methods will be level 2 helper methods for the insert function. So we go till level n helper methods for generating a summary for a dependent method. Okay, and if the method is independent, these things don't come and we don't give any helper methods information in the prompt. Okay, then after designing the prompt, we prompt to LLM. We used several combination of LLMs for our study, and then after passing it to LLM, we get the comments generated by it, and then we evaluated the quality of the comment by automated metrics available in the literature, and also we check the quality of it by doing a developer survey of around 160 peoples. So that was our methodology. So here are the results. So for RQ1, we see what are the evolution of independent and dependent methods. So we took 10 projects, so there were around 648k methods. Among them there were 450 dependent methods, which are around 70%. So you can see that in practice dependent methods are more obvious in real world projects than independent methods. And we also found that 77% of the commits belong to dependent methods. So in GitHub, like for the projects, like 77% commit changes were associated with dependent methods. And we also found that the author engagement is higher for dependent methods than independent methods. You can see in the box plot too, where we plotted the frequency of commit and engagement by method types, and this triangle is indicating the mean value of each distribution. So d commits and I commit. So you can see for dependent methods, commits related to dependent methods are higher in frequency compared to commits related to independent methods. Also the author engagement related to dependent methods is also higher than the author engagement related to independent methods. So that proves that dependent methods are of more importance in real world projects than independent methods. So focus should be given to generate quality comments for these kind of dependent methods. Okay, so then we move on to see how the baseline performance performs on the dependent and independent method, and is there any difference between them. So on our total data set, we run experiment with models Codify Plus and CodeBart to see how they are performing. So we found that the synthetic similarity matrix, Blue, Meteor, and Rouge, and also the semantic similarity matrix, either as sentence bird, universal sentence encoder, and another site. And we see that the score of these metrics are very low. Suppose for Blue is, you can see it's 2.3, and which is very low. But in literature, like people have found that it's around close to 15 or something. So we assume that because the functions dependent and independence are merged here, we assume that for dependent methods it's not doing well. So to prove our assumption, we move forward, and for before that we also defined a metric like overall metric score. What and for double S is like syntactic similarity and semantic similarity. So we gave syntactic similarity a bit low score than the semantic ones, because the quality of the comment should be semantically more equivalent rather syntactic, because you can know like two semantically equivalent comments may not be syntactically equal, but they we can convey same message. So this is a metric, so it's basically following the equation here and generating scores. So yeah, we found that low scores over all the metrics, but we see higher scores in literature. So does the method type affect model performance? So for that we divided the methods and again run the baselines. So this time we also included another baseline, ASAP, which is LLM based, and we apart from the syntactic and similarity metrics, we also included LLM based evaluation, like we prompted GPT-4 and also Llama 3.3 to check the quality of the generated comments. And as you can see that for and for that we also defined another metric, is OMS SSL. It is just including the LLM part with the syntactic and similarity metrics part, and to convey a total metric score. Okay, so we can notice that for almost each cases the results for uh, independent methods are better than dependent methods. Okay, so what does that mean? It means that, like, the current existing models is performing good for generating comments for independent methods, like 7 to 13% you can see. And but for dependent methods they are lagging behind. That means the current methods are not tailored for dependent methods. They might do well for independent methods, but their generated comments are not of good quality when the methods are of dependent methods, when the methods depends on helper methods. So research focus should be given to these kind of methods. For this we proposed a technique, helpcom, with utilizing LLMs and the helper methods to generate better summaries. We already showed you in the methodology how we generated the summary, and here we compared the help come with other approaches and over three matrices, like three group of matrices: syntactic, semantic, and LLM evaluation. And we also have the overall score, OMSSS and OMSSSL. And our approaches are like the baselines are code T5 plus, code parp, ASAP, which is LLM based. And we and ASAP used like GPT 3.5 in their study. We also tried with ASAP with GPT 4o, and we utilize GPT-4o normally, and code llama 3.3. And for our helpcom we used GPT-4o, llama 3, and code llama as the LLM. And also you can see there is 1 and n suffix given, which means, like, one means one level 1 helpers, like one variant of helpcom just takes helper methods till level 1, and another variant of helpcom takes helper methods to level n, like till how many helpers are possible. And we all and then we generated the scores, and you can see the bold ones are the best score for each metric. And you can see all for almost all cases helpcom with n level using GPT-4o has outperformed all the baselines and all variants of helplines in almost all the metrics except two, I guess. And but in overall scores, helpcom level n with GPT-4o stands out the best one. And the star ones means the difference are statistically significant when compared with helpcom and GPT-4o with other techniques. Like for helpcom and with GPT-4o performs better than helpcom 1 code llama on blue, and the difference is statistically significant. And you can also see that we got total 5 to 50% improvement in overall metric score. Okay, so here we prove that utilizing helper methods to generate quality comments for dependent methods actually improves the quality of the generated comment. Okay, so here we can see an example to qualitative analysis for our technique. Like suppose here is given a function stop random data node, which depends on the function ensure open, which is a helper method. We also give the implementation of ensure open here, and you can see it is the ground truth summary that is originally written by developer, which says stops a random data node in the cluster, returns true if a node was found to stop, or false otherwise. But you can see the existing models CodeBart, CodeTifly Plus, or ASAP, their summary is kind of short and it's not detailed. Like it just says stops a random data node and close its client. But our helpcom, it says it stops the data node in the cluster if available, ensuring the cluster is open. So it takes helper methods info and also is open, ensuring the cluster is open before attempting to stop the node. So you can see our summary is kind of like mostly aligned with the summary written by developer here, the ground truth summary, which proves that like qualitatively helpcom includes more info, rich contextual info to understand the method rather than the other baseline techniques. And finally, we did a developer survey to check the quality of our generated comments. So we got 162 survey responses and 6 were incomplete, and we gave 3 tasks and each have 3 subtasks. So the task was like first like comprehend a method without any helper method, and then we give again that method and we gave the implementation of helper method too, and then we ask the developer to comprehend that method. And finally we ask the developer like choose the best summary that conveys the implementation of the method among 3 options, and among the 3 options one was helpcom generated output and another 2 was randomly selected from the baseline outputs. And 75% of the participant chose helpcom solution. That means that developers also felt that the quality of the comments generated by helpcom was better in conveying the complexity of the dependent methods when compared with the baseline ones. And in the right side figure you can see that how was the stressed people felt when they were needed to comprehend the method without helper, and then blue ones are the with helper. So 1 2 means difficult, and maybe 10, if they give 10 it means easy. So you can see that for the red ones are without helper. So for the all cases the blue ones like were better, like the score frequency of the blue ones, like so when people were provided the helper methods information, they were able to easily comprehend the function more than rather than when they are not given helper methods function. So people's behavior are also aligning with the proposed helpcom solutions internal methodology. So that proves that we giving contextual information like helper methods information when generating comments for dependent methods actually helps and is also a human nature. And we have some implications for our study. Like for researchers, helpcom's performance opens new doors in research. Like now people can, like researchers can utilize or explore more ways how they can give context of the function dependencies to generate more qualityful summaries. And future research can go further building on our findings. And for software maintenance they have to be careful as to choose an ideal tool for comment generation, as we prove that like baseline tools are not that much good when there are dependencies inside a function. So they should prioritize those tools whose generated comments are semantically meaningful rather than syntactic matches. And for novice developers also they should be aware while using automated tools, because the tools do not give much semantical information, so whenever they face confusion they should always ask for expert opinion in case of confusion to understand the method better. So to summarize, we introduced a novel approach, helpcom, that utilizes helper method context to improve comment generation for dependent methods, and we built a custom dataset of 10 popular Java projects and linking dependent and helper methods. So this is the first dataset in the literature that also includes the helper methods implementation in regards to dependent methods. So that's a good contribution we can claim for the research. And we also found that about 70% of the methods are dependent, highlighting that dependent methods are more prevalent in literature than independent methods, and focus should be more given to dependent methods while generating summaries of those methods. And we also find out that existing baselines perform poorly on dependent methods compared to independent ones, and our solution helpcom outperforms baselines by 5 to 50% in overall metric score, which shows that how useful it is through giving context while generating comments. And finally, our survey of 156 developers confirmed helpcom's effectiveness and clarity. So that's it. Thank you all. I would like to acknowledge the answer create in software analytics research short fund for funding this research, and this is our contact information. If you like to know anything, please contact us, and thank you.